Hello, this is Charlene. We're going to be talking about some probability today. Two different scenarios. There's an independent scenario. That independent scenario is where we randomly select two marbles from a bag with replacement. So let's say that this is my bag of marbles down here, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9 marbles. But I'm going to take one of these blue ones out. And I'm going to say, it's a blue marble. But then guess what I'm going to do? I'm going to put the blue marble back in the bag. So I still have 9 marbles. I started with 9 marbles. I put it back in. I still have 9 marbles. So now I'm going to take a green marble out of the bag, and I have 8 marbles. So the thing is, though, is that when I took the blue marble out, I had 9 marbles. When I took the green, I still had 9 marbles. So my total number of marbles did not change. So the first marble that I pulled out of the bag had nothing to do with me pulling the green marble out. I was still pulling out of a total of 9 marbles. So this idea of the independent situation is that the total number is not going to change. When it's independent, the total number does not change. So the formula for finding the probability of selecting two marbles when they are independent of each other is the probability of A and B. That's the probability of pulling one marble out and then pulling another marble out. And we are going to multiply the probability of the first marble times the probability of the second marble. Again, the total does not change. So the way that we would write that is that I have 4 marbles that are blue. So if that's the first one I'm pulling out is that blue marble, that means that I would have 4 blue marbles out of a total of 9 marbles to choose from. And then when I pull the green marble out, I have 2 green marbles. So that means I have 2 green marbles, but I still had a total of 9 marbles to choose from. So when we want to find the probability of two different events, the first event and the second event, we will multiply those two probabilities together. When they are independent of each other, the bottom line total does not change. The total number does not change when it is independent. Okay, so let's talk about what it means to be dependent. Okay, so we've got this dependent situation over here, dependent. And this means that we are going to randomly select 2 marbles without replacement. That is the dependent situation. So now I'm going to take this blue marble and I'm going to pull it out. And I'm not going to put it back in. So I started out with 9 marbles in my bag, but now that I pulled 1 marble out, I only have 8 marbles left in my bag. So that means that now that I'm going to pull out the green marble, my probability has been affected. This first marble that I pulled out right here, the first marble that was blue, it changed my total number to 8. So the second probability is changed. So that is the difference between independent and dependent. Dependent means that the total number does change. It means that this second probability of pulling the green marble out, it was somehow affected by the fact that I took 1 marble out and my bottom number, my total number changed. So I've got these 2 different formulas that I have to choose from anytime I'm looking at the probability of doing something and the probability of doing a second thing. So again, this can be kind of hard to get your brain around, but we're going to do some examples that's going to help us to understand. But again, it is about the first thing and the second thing, like pulling a marble out and pulling a marble out again out of a bag of marbles. But in this first one, the independent situation, the probability, the total number does not change. So I do not have to change the total number. But in the dependent situation, something happens to the second probability. That is what this part of this formula addresses. This part changes. It changes from a normal, simple probability because the total number does change, and the probability of the second thing is affected by the probability of the first thing because that total number is going to change. Okay, let's look at our first example. It says our instructions say to randomly select two marbles with replacement, which will be independent. So if we are taking a marble out and we're putting it back in, is our second probability going to change? No, because it's completely independent. It's like we're going to put it back in. We're going to start out with 9 marbles. We're going to put it back in, replace it. It'll still be 9. So your probabilities will remain balanced and independent of each other. So we're going to choose this version of our probability formula. And again, just to remind us, that means that the total number does not change. So our problem says the probability that both marbles that we're going to pull out of the bag are blue, which means the probability that the first marble we pull out of the bag is blue, and the second marble that we pull out of the bag is also blue. So we need to look at how many blue marbles I have. How many blue marbles do I have in my bag? I have 4. 4 blue marbles out of a total of 9 blue marbles. And I'm going to multiply that. Multiply that times the probability of a blue marble the second time. So again, I put it back in the bag. I replaced it. And so therefore, the probability of the second event is completely unaffected by the probability of the first event. So I'm still going to have blue marbles, 4 blue marbles in my bag because I put it back in the bag. I replaced it. So it's going to be 4 ninths times 4 ninths, and that is going to give me 6 out of 81 probability. And if we want to change that to a decimal probability, we can divide that. 16 divided by 81 is equal to 0.197. And then we can round that to 0.20. So it's about a 20% chance that if I have a bag of 9 marbles and I pull a blue one out, I put it back in, and I'm going to pull out another blue one, there's about a 20% chance or probability that that will happen. Okay, so our next problem is still about the independent scenario. The independent scenario uses this version of the formula. The probability of A and B is equal to the probability of the first thing times the probability of the second thing, which means that the total number does not change. The second probability is unaffected by the first probability. The second event is completely independent of the first event. So it says that we are going to first choose a blue. We want to know the probability of first choosing a blue and second choosing a green marble. So we have to look at the blue marbles first. How many blue marbles do I have? I have 4 out of a total of how many marbles in my bag? Well, there's a total of 9 marbles. So 4 out of 9 is my probability of the first event, which is the blue marble. And then I'm going to multiply that. So multiply that times the probability of the second event. And the second event is that I'm going to pull a green out. However, I did replace that blue marble in the bag. So that means I still have a total of 9 marbles. But how many green options do I have? I have 2 green marbles to choose from. So it's going to be 2 ninths probability of choosing a green marble. I'm going to multiply those two probabilities. 4 times 2 is 8 in the numerator. 9 times 9 in the denominator is 81. And if I want to go ahead and divide that out, then I can actually get a decimal percentage. And it kind of makes more sense to our brain sometimes when we do that. So that is going to be equal to 8 out of 81 probability that we'll choose a blue the first time, and a second time we'll choose a green marble, and it's going to be 0.098. And if we round that to 2 decimal places, that'd be 0.10. So there's about a 10% chance that we will first choose a blue marble, we'll put it back in the bag, and the second time we will pull a green marble out of the bag, about a 10% chance. Okay, now our instructions say to randomly select 2 marbles without replacement. So they're changing things up on us. Without replacement means that these two probabilities are going to be dependent. The second probability is going to be dependent upon the first probability. So the second probability is going to change. We are going to use this version of the probability of two events happening, because the second probability, if we do not put that marble back in the bag, that means that it's going to change the total. The total does change when it is a dependent situation. So we're going to use this version of the formula, and we are not going to use this version of the formula. The second probability is going to be affected. Okay, so they want us to do the probability that both times we pull a marble out of the bag, that both times it is blue. So both blue still means the probability of blue and the probability of blue. So the first time I have 4 blue marbles, so that is going to be 4 marbles out of a total of 9 marbles. However, when I take that blue one out, I no longer have 9. I now only have 8 marbles left in my bag. So I also have reduced the number of blue marbles. So I now only have 3 marbles. So I'm going to multiply that, because we're still multiplying the two probabilities, but the second one is changing. Now we only have 3 blue marbles, and we only have a total of 8 marbles. So when I multiply those together, 4 times 3 is equal to 12. And 9 times 8 is equal to 72. And I can go ahead and divide that out and see what the decimal version is. So that means it is going to be equal to 0.166, which if we round it to 2 decimal places would be 0.17. So the probability of getting both blue marbles when we do not put the marble back in the bag is a probability of 12 out of 72, and it's about a 17% probability that we will get a blue both times without replacing. That is a dependent situation when we do not put the marble back into the bag, and the second probability is affected by the first event. Okay, the next directions say randomly select 2 marbles without replacement. That makes it dependent. If we're not putting the marbles back in, then the second probability is going to change, which means that this probability that shows the second probability is different from the first one. That is the formula that we will choose to use, where the second probability changes. The total number of marbles is going to change. Okay, so we've got the first probability, the first marble is a blue, and the second probability that the second marble we choose is green without replacement. And we're going to use this formula where the second probability total is going to change. Okay, so how many blue do I have? I have 4 blue, so that's 4 out of 9. I'm going to multiply that. We always multiply when we got an and probability. We always multiply our probabilities. So 4 out of 9 is the probability of getting a blue first. The second probability is a green. So we've got 2 green, but now we only have 8 marbles in the bag. That is reflected in this part of the formula where the second total is changing. Okay, we're going to multiply that. 4 times 2 is 8. 9 times 8 is 72. And if we reduce that, 8 out of 72 is 1 out of 9. And if I go ahead and put that in my calculator, that will give me a decimal of 0.11. So the probability that I will choose first a blue marble and then a second marble we chosen, and it will be green, is a probability of 1 out of 9, which is also 0.11 in decimals, which means about 11% probability that that is what will happen if we do not put the marbles back in the bag, and they are dependent events. Okay, this time it says that we are going to select 3 marbles, not just 2, but 3. But again, it is going to be without replacement, and that is going to create a dependent situation. When it is a dependent situation, that means that our subsequent probabilities are going to be affected. It is dependent upon the previous event and how it changed the total, because the total number will change with each subsequent probability. So we're still going to be multiplying our probabilities. We're going to multiply the probability of a blue times the probability of a red times the probability of a red again. So the first one is going to be the blue. I have 4 blue marbles over here, and 4 out of 9 is what I start out with. Multiply that times the probability of a red. Okay, so it is a dependent situation. We're not putting the marbles back in the bag. That means that there is one less possibility. That is that dependent relationship, one less possibility. So I'm only going to have 8 marbles in the bag. But this time we're talking about red, but I still have 3 red in the bag, even though one of the blue is gone. So 3 out of 8 is the probability of the red. I'm going to multiply that times taking another red. Well, my red, I've taken one of the reds out. That leaves me with only 2 red left. And I've also reduced the total number in the bag of marbles to 7. So now I can multiply all of those numerators straight across. 4 times 3 times 2 is equal to 24. And 9 times 8 times 7 is equal to 504. So we're getting to big numbers in our fraction. But that fraction will reduce to 1 over 21. And then if I put that into my calculator, that will give me a decimal. The decimal is 0.047, which would round to 2 decimal places, 0.05. So that means that our probability of drawing 3 marbles without replacement, a blue, a red, and a red, is a 1 out of 21 probability, which is also 0.05 in decimals, which is about a 5% probability that we would draw a blue, a red, and a red. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.